Good morning, everyone. I'm about to review for the midterm Algebra 2 exam. So number one, first of all, if you'll look under my materials, you'll find the copy of the review that I made up. And now I'm going to go over them, so please just copy this as you would notes. Self-check if you've already done it yourself. Combining functions and composition of functions. We did this, but it's been a while, so a little review here. When you add two functions, f of x plus g of x, given f of x equals x plus 7, g of x equals 3x plus 2. So when you combine the two, you're just going to copy the two original functions, and you're just going to combine them, combining like terms. X plus 3x is 4x, 7 minus 2 is 5. Going to 1b. This is a composition of functions. The way that we address this is, first we write the outside equation. So I wrote it 3 in place of the x. We're going to leave a hole for whatever the inner function is, and then subtract 2. So you're going to substitute the inner function, and you're going to simplify. So what was f of x? We were given f of x is x plus 7. Substitute it in here. To simplify this, you're going to distribute that 3. 3 times x is 3x. 3 times 7 is 21. Subtract the 2. Again, we combine like terms, and so the 3x stays. 21 minus 2 is 19. Going to 2a. They want you to solve for g of x, f of x plus g of x, given f of x is x minus 3, g of x is 4x minus 1. And again, I'm just going to substitute into the f of x and the g of x. I'm going to combine like terms, and so 1x plus 4x is 5x, and negative 3 minus 1 is negative 4, and your final answer is 5x minus 4. Again, I'm not going to do all the ones because some of them I've given you the explanation in your review sheet. Okay, let's go to problem number 3. Number 3 is just a simplifying an expression. So the rule, the exponent product rule, is x to the m raised to the p is x to the m times p. Again, that's the product rule for exponents, and we simply multiply the powers. If you recall, I tell you whenever you're missing an exponent, please put in a 1. So 1 times 3 gives me 4 to the third power. 1 times 3 for the x gives me x to the third power. 2 times 3 gives me y to the sixth power. Remember that 4 to the third power means I have 3 of the base of 4. So that's 4 times 4 times 4. X cubed y to the sixth for a final answer of 64, x to the third y to the sixth. A second example, 3x cubed y, all that raised to the fourth power. Again, notice I've inserted the ones and the exponents that are missing. It's a good strategy, and it helps you not to lose or make a mistake with a product rule. So 1 times 4 is 4, and 3x to the 3 times 4 will be 12, and y to the 1 times 4 will be y to the 4th. So my answer appears to be 3 to the 4th, x to the 12th, y to the 4th. Remember, in SATs, they probably wouldn't leave that either. They're going to simplify that. So 3 to the 4th power is 3 times 3 times 3 times 3, 4 times, which gives us 81, x to the second, y to the 4th. Moving on to number 4. We have f of x is 10 times 3 to the x power. There's different notations for multiplication, so I've shown you both here. I prefer this one in parentheses. You also will see the dot. I do not like the multiplication dot. To me, it's a floating decimal, so 9 times out of 10, I'm going to give you this. However, I did not make up the midterm, so we're going to use what we have, and they've used the dot to notify us that we're multiplying. So I'm going to insert each of the x values into the f of x function. So each time I'm substituting the 0 in for the x, the 3 in for the x, the 6 in, and the 9. So anything to the 0 power is 1. 10 times 1 is 10. 3 to the third power is 27. 3 times 3 is 9. 9 times 3 is 27. Multiply that by 10, you get 270. 10 times 3 to the 6th, well, 3 to the 6th is 729, times 10 gives me 7,290. And lastly, when x is 9, 3 to the 9th power is 19,683. I multiply that by 10, and so that's my final answer there. The one that they're asked to fill in is this one. The other answers are provided, but I wanted to explain where they came from. Here's 4b. This is 20 times 5 raised to the x power, and I've given the x values of 0, 4, 8, and 11 to insert as your input, and your output will be your f of x. 5 to the 0 power is 1. 20 times 1 is 20. 5 to the 4th power is 625, times 20 is 12,500. When x is 8, I get 5 to the 8th power, which is 390,625. You multiply that by 20, there's your net result. And when x is 11, 5 to the 11th power, nice big number there. We have 48,828,125, which you then multiply by 20. And I see that I put the commas in the wrong place. This is what happens when you are working until 4 in the morning. Anyway, so if you want to go ahead and put those commas in the correct place, now, if I was Sal from the Khan Academy, you'd have a little note come up from the bottom of the screen. Sal just made a mistake. He should have said. Okay, but anyway, so I have 97 million. Did I do that right? 976,562,500. That comma's between the 6 and the 5. All right, so moving on, we did 1, 2, 3, and 4. We only have 5 and 6 left. And I'm trying to keep this one not quite as long as my last one. Here we go. This is number 5. This one's a little bit harder. We haven't done these in a while. Factoring when a does not equal 1. So my leading coefficient is not a 1. We need to factor this first. So 2x squared can only be 2x times 1x. And then you're going to factor the c term. So I have -7, so I only have two options. Either it's +1 times -7, or it could be -1 times +7. So I just went ahead and plugged in the first one. Again, you can always just use guess and check method. This, using a strategy, is a little more time consuming, is a little more time saving is what I want to say. The guess and check is more time. So I have 2x plus 1 times 1x minus 7. Let's distribute that 2x. 2x times 1x is 2x squared. 2x times -7, -14x. 1 times 1x is +1x. 1 times -7 is -7. We combine like terms to simplify, and we find our b term to be -13x, and yet we wanted +13x. So that's a no match. So then we try the other alternative. 2x, now the 1 is minus, and the 7 is the plus 1. So 2x times 1 is 2x squared, plus 14x, distribute the -1. -1 times x is -1x. -1 times 7 is -7. Now when I combine like terms, 14x minus 1x gives me that 13x. And so if I go back and look at the original, and I come over here, we say, yes, these two quadratic equations do match, and therefore the factorization, the correct factorization is 2x minus 1 times 1x plus 7. Going to 5b, this is the second example. So I have 3x squared minus 7x minus 10. We're going to factor our leading or our a term. 3x squared only can factor into 3x times 1x. Again, 3 times 1 is 3, x to the first, times x to the first is x to the second. We're going to factor the c term. Now, this one has more possible options. So 10 is either 1 times 10 or 2 times 5. However, since it's -10, you have to try -1 times +10, +1 times -10. And so you could, through trial and error, try the different possibilities, and then you will find that this will be the one that finally works for you. 3x times 1x is 3x squared. 3x times 1 is 3x. -10 times 1x is -10x. -10 times 1 is -10. Combining like terms, I have 3x minus 10x gives me that -7x from the original equation that I'm looking to match. The 3x squared in the front checks with the original, and the -10 in the back also matches with the original. And so that is your correct factorization, 3x minus 10, 1x plus 1. Okay, we're doing great on time here. Let me go to problem number 6, and then we are ready to go. Okay, so we're going to add algebraic fractions. This is very similar to adding regular old fractions, 1/2 plus 1/4. And so you're looking for a common denominator, in this case, a least common denominator, because we don't want to have to reduce later on. So looking at 4 and 9, I made a list of all the multiples of 4 and 9. 4, 8, 12, 16, 20, 24, 28, 32, 36. You just add 4 each time, or 4 times 1, 4 times 2. Now I'm going to list all multiples of 9. 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. Bingo, that's our LCD for the coefficient. Next, I have to look at the algebraic component. Well, I have an x and I have a y, so the least multiple I can possibly get is xy. So our whole least common denominator is 36xy. So let's go over here. I have 3 over 4x plus 2 over 9y given, and you're told to add these. So what I need to do is multiply by a form of 1 that will get me to the least common denominator, and then we'll be able to add these two fractions. Well, if you say to yourself, 4 times what equals 36, and that gives me 9. I have the x, I need xy, and so that's where I got that 9y from. You may notice it is the opposite denominator, but that's not always going to be the case. For the second one down, I have a 9y, and I need 36xy, and so I realize that I need a 4x for the form of 1 that I multiply it by. This gives me 8. Sorry, guys, I'm having some technical issues here, holding and not dropping everything. Okay, so let's multiply straight across. 3 times 9y is 27y. 4x times 9y is 36xy. 2 times 4x is 8x, and 9y times 4x is 36xy, giving me a grand total of 8x plus 27y over 36xy. Please note that we put the x term in the front and the y term in the back because we, common math notation is we use alphabetical order. So again, A, B, C, D, x comes before y. Looking at 6a, so that was 6b, and I did also do 6a, even though it is on my midterm review already solved for you, but I wanted to explain it here. So we have 2x and we have 7y, and so I did the same thing. I took all multiples of 2, 2, 4, 6, 8, 10, 12, 14, multiples of 7, 7 and 14. So 14 is the least common denominator for the coefficient component. Again, this is an easy way to find your LCD. The least common denominator between x and y is still xy. So the whole denominator, the least common denominator that we can find, is 14xy. So again, I go back to my original problem and I say, what form of 1? Because remember, 1 is our multiplier. When you multiply anything by 1, you get back to the original. All right, that's called our multiplicative identity. When you multiply by 1, it does not change your original input. So I do 4 times 7y gives me 28y. 2x times 7y gives me 14xy. In the bottom, I had 7y, and I knew I needed 14xy for the LCD, and I said 7 times what is 14, and that's where I got that 2x from. And whatever I do to the bottom, I have to do to the top. And 9 times 2x is 18x. For a sum total of, now remember these are two, they're not like terms, so I cannot put them together. I'm not multiplying, I'm adding. Notice again that the x term goes in the front, the y term goes in the back, for a final answer of 18x plus 28y over 14xy. I hope this has helped everyone get ready for our midterm. This is day 1. Tomorrow you will have questions 7 through 12, and then you should be ready to do your midterm on Wednesday. Everybody have a great, safe day.